All right, welcome back. So we got this problem, the Empire State problem. How tall is the Empire State Building? Okay, so we're given this information. We've got a neighboring building. We're at the 13th floor, and that's 128 meters above the ground. Okay, the angle of elevation to the top, that should be to the top, sorry. To the top of the Empire State Building is 59.4 degrees, while the angle of depression to the base is 40.2 degrees. How far apart are the buildings and how tall is the Empire State Building? Okay, so let's draw a little picture. Here's my neighboring building. And we're on the 13th floor. We'll just say that's only 13 floors. Bad luck, I know, but we don't believe in bad luck. So this has a height of 128 meters. Okay, I'm a big fan of using variables and then plugging in the numbers at the end. It's just how I think things should be done. Okay, so our height one is 128. We've got our Empire State Building over here next door. We're going to assume they're on the same height. Okay, there's no crazy mountains going on. Okay, angle of elevation to the top. So you've got let's call this theta 1 is 59.4 degrees. Okay, angle of elevation to the bottom, or angle of depression to the bottom. That's going to be 40.2 degrees. Let's call that theta 2. Okay, let's call this little thing y. Okay, and let's call this distance between them x. Now, here, h1, this distance h1 is the same as this distance h1. Okay, so we already know that point. Okay, so what do we have? A couple of things. First, we can find this x. Okay, we know that the tangent of theta 2 should equal h1 over x. What do we know? We know the angle. We know h1. We just need to find x. X is going to be what? h1 divided by tangent of theta 2. I'll calculate that a little bit later. Okay. Now, once we have x, we just need to find this y. Okay, but y over x equals tangent of theta 1. Assume we know this x because we found it here. Okay. So y equals, what's that? X tangent of theta 1. Okay, we'll figure that out later. Okay. Now, our height, our total height is really h1 plus x, or I'm sorry, plus y. So that's the last thing we're going to need to find. Okay, let's go ahead and put these numbers in. Okay, so first, let's move these around a little bit. There we go. Okay, h1 is 128. Tangent of theta 2. Make sure you're in degrees when you calculate this. So 128 divided by 40.2 tangent equals 151. 0.463 let's say 8. Okay, and let's see, that tells us to rounded it to the 10th, so it rounded it to 151.5. Okay, now I'm going to really be a little bit extra with my saying like, hey, let's not use any numbers we don't know. Okay, so I'm going to take this answer. I'm going to say, okay, y equals, I'm not even going to write out x. I'm going to write 128 divided by tangent of 40.2. That's my x. Times tangent of 59.4. So what do I get when I calculate that? 128 times 59.4 tangent divided by 40.2 tangent. I get 256.117. Let's approximate that to 256.1. Okay, and let's add that to our 128. I guess they rounded it to the nearest meters because they took 128 plus 256 to get 384. Okay, so the answers that we were asked for again were the x, the distance between them, and the height, which was 384. Okay, see you in the next problem.